Okay, good morning, students. Good morning, students.
Good morning, sir.
Okay. So today we are going to discuss about uh, VSWR, voltage standing wave ratio, and we are going to discuss about reflection coefficient. So last class we have seen what is input impedance. What is input impedance for different types of short circuit, open circuit, and also the line terminated with some characteristic impedance. Hope all of you are fine. Bhargav is there. Bhargav,
సార్
లాస్ట్ క్లాస్ ఏం చెప్పానమ్మా? లాస్ట్ క్లాస్ ఏం చెప్పాను? ఇన్పుట్ ఇంపిడెన్స్ చెప్పాను. Zn equal to Z0 into ZL plus J into Z0 tan beta L by Z0 plus J into ZL into tan beta L. So this was the equation I explained in the previous class. I have explained a problem also. Now today's class we are going to see what is this voltage reflection coefficient. So reflection coefficient is mostly used in many of the applications. So what is this reflection coefficient? First question is, why reflections occur? Reflections ఎందుకు వస్తాయి ట్రాన్స్మిషన్ లైన్ మీద? ట్రాన్స్మిషన్ లైన్ లో సోర్స్ ఉంటుంది, లోడ్ ఉంటుంది. So see the screen here. Source will be there at the starting, at the end load will be there. So there are some conditions when reflections occur on a transmission line. First condition is when the source impedance ZS is not equal to the load impedance, that is ZL. Are you following, students? When the source impedance is not equal to load impedance. Source impedance ante enti? Source impedance is at the sending end, at the point where we are connecting the source, it is having some impedance. So this impedance should match with the load impedance. So if it is not matching, that means mismatch, and there are reflections on the transmission line. Second condition is the primary constants R, L, G, and C. What are the primary constants in a transmission line? Resistance, inductance, conductance, and capacitance. If they are not uniform along the length of the transmission line, then reflections occur on a transmission line. This is the second condition. One more third condition is also there. That is when the transmission line is open circuited. For example, take a parallel wire. So it is open circuited, and one side I am connecting the source, the other side it is not closed. So what happens? So the current or the voltage will travel on the transmission line, go in the forward direction. సో ఇక్కడ ఎండ్ దగ్గరికి వచ్చేటప్పటికి ఇంకా దారి ఉందా వెళ్ళడానికి? లేదు. సో ఏమవుతుంది? ఇది ఎలా రిఫ్లెక్ట్ అవుతుంది? సో ఇట్ విల్ బి going in the backward direction. So in these three conditions, there are reflections on the transmission line. Another condition is also there. That is cavity. Cavity means it is closed on all sides. So inside cavity, if you are launching any wave or any signal, so cavity means it is closed on all the sides. Suppose take for example a ball. ఆ బాల్ ని ఒక చిన్న రూమ్ లో ఇట్లా మనం హిట్ చేసాం అనుకోండి, ఏమవుతుంది? ఆ బాల్ ఆ రెండు వాల్స్ మధ్యలో అది అటు ఇటు ఆసిలేట్ అవుతా ఉంటది, రైట్? సో లైక్ దట్, even the electromagnetic wave or the voltage or current wave, it will bounce when all the walls are closed. So like this, reflections occur in a transmission line. Reflections occur in a transmission line. So now, based upon this, I am going to calculate the reflection coefficient. There are two types of reflection coefficients. One is voltage reflection coefficient, second one is current reflection coefficient. Now look here. In this transmission line, I have connected this to a source. So there is a forward wave traveling like this. This blue color indicates forward wave. Blue color is forward wave. So like this, it is traveling in the forward direction. It's traveling in the forward direction. Next, this is indicated by this sign, arrow mark, blue color arrow mark. So when there are reflections, what happens is this will reflect back. See, this is the red color indicates the reflected wave or the reverse wave. See the color difference. Blue color indicates forward wave and red color indicates reflected wave. Now here, the reflection coefficient is defined as the ratio of amplitude of the reflected wave to the incident wave. The amplitude of the reflected wave to the incident wave. So here, thank you. So here, if you take the voltage, it consisting of incident wave and reflected wave. It consisting of incident wave and reflected wave. So how can you define reflection coefficient? It is the ratio of amplitude of the reflected wave to the incident wave. So now it can be written as VR by VI. This is the definition for reflection coefficient, where rho is reflection coefficient. Sometimes it will be represented like this, eta or rho. All these Greek letters, they are used to represent different constants. Now reflection coefficient is represented with rho generally, or eta. So ZL is the load impedance and Z0 is the characteristic impedance. Now, what do you mean by load impedance? In a transmission line, there is a source, there is a load. If you calculate the impedance at the load, it is called as load impedance. Now at the load, VL is equal to VI plus VR. At the load, VL equal to VI plus VR. It is equal to incident wave plus reflected wave. Now characteristic impedance can be defined as, it is the ratio of forward voltage to the forward current. That is one definition. So it is given by VI by II, or it can also be defined as the ratio of negative of reflected voltage to the reflected current. See the difference? When you are taking the ratio of incident, it is a positive. When you are taking the ratio of reflected, it is negative. So this is the definition for characteristic impedance. Now, IL equal to, what is IL? The current at the load is equal to II plus IR. Now, IL equal to II by IR, II plus IR. So II is the incident current and IR is the reflected current. Now this can be written as, what is II incident current equal to VR by Z0, VR by Z0, VI by Z0, and what is IR from this equation? IR is minus VR by Z naught. So IL can be written as VI minus VR by Z naught. Now we are going to calculate the ratio of voltage to the current at the load. So now we are writing ZL equal to, ZL means at the load. So here it is ZL. So ZL equal to VL by IL. So what is VL? VL is nothing but VI plus VR. What is IL? VI minus VR by Z naught. So VI plus VR by VI minus VR by Z naught. So Z naught ఎక్కడ ఉంది, డినామినేటర్ లో ఉంది కాబట్టి న్యూమరేటర్ లోకి వస్తుంది. So this equation becomes, now Z naught, if you remove here, it will come to the numerator. So you can write this equation as VI plus VR into Z naught. Now here we can take here is equal to ZL. Now cross multiplying VI Z naught plus VR into Z naught is equal to ZL VI minus ZL VR. That is what I am writing here. VI Z naught plus VR Z naught equal to VI ZL minus VR ZL. Now now multiplying this equation with VI on both sides. Sorry, dividing this equation with VI on both sides. Z naught plus VR by VI into Z naught equal to, we are dividing with VI, so ZL minus ZL into VR by VI. So what is the definition of, this is the same equation what I have written here. So what is the ratio of VR by VI? It is nothing but rho. So this can be written as VR by VI into Z naught, here minus, if it comes this side becomes ZL. So Z is equal to ZL, here it is plus, it becomes minus. So now if you take this Z naught plus ZL this side, so how can you write? VR by VI equal to ZL minus Z naught by ZL plus Z naught. So this is the very important formula to find the reflection coefficient. So VR by VI equal to ZL minus Z naught by ZL plus Z naught. So this is what we are going to write here. Now here, if there are some conditions. Remember this formula, ZL is the load impedance and Z naught is the characteristic impedance. And here, case 1, if ZL equal to Z naught, what happens? So in the numerator, ZL minus Z naught. So here substitute ZL, or here you can substitute Z naught. So 0 by something, it is 0. So then reflection coefficient will be 0. Second, case 2, when ZL equal to 0. So substituting ZL equal to 0, minus Z naught by plus Z naught. Z naught will get cancelled, 1 minus 1. So reflection coefficient is equal to minus 1. The third condition is when ZL equal to infinity. So when ZL equal to infinity, so this becomes 1 minus Z0 by ZL by 1 plus Z0 by ZL. So these two values will become 0, 1 by 1 is 1. So ZL equal to Z0 ante, then meaning enti? Characteristic impedance equal to load impedance. Then reflections will not be there. That is the meaning of reflection coefficient is equal to 0. Reflections లేనప్పుడు reflected wave లేనప్పుడు మనకి reflection coefficient definition ఏంటి? Reflected wave by incident wave. When there is no reflected wave, what will be that value? It will be 0. So then reflection coefficient will be 0. Okay. Second case, when ZL equal to 0. ZL equal to 0 ante short circuited. Transmission line low. So I will be drawing this here. If it is short circuited, what happens to the voltage? Voltage is equal to 0. So what is the value of ZL? ZL equal to VL by IL. When VL is equal to 0, so ZL equal to 0. So rho equal to minus 1. Very, very important, all these values for reflection coefficients. The reflection coefficient is equal to minus 1 means the transmission line is short circuited. Next, ZL equal to infinity. What is the meaning? See, if it is open circuited అంటే ఇక్కడ కరెంట్ ఏమన్నా ట్రావెల్ చేస్తుందా? ట్రావెల్ చేయట్లే. అంటే కరెంట్ ఏమవుతుంది? 0. So VL by IL, something by 0 is infinity. So rho value is equal to 1. So these are the three values you have to remember when you are taking the values for reflection coefficient. Now, see here in the examination JNTU, he will be asking, write a short notes on reflection coefficient and VSWR and derive the relation between them. So at the time you can derive the equation like this. Whatever I am showing you on this slide, you can write it in your answer book, and you will be getting 7 marks. So reflection coefficient is defined as ratio of reflected to incident voltage, eta equal to VR by VI, or minus IR by II. So we know that the voltage and current expressions V equal to A e power minus Px, B e power Px. I equal to 1 by Z0, A e power minus Px minus B into e power Px. These are the two equations we have derived from transmission lines. Now, if you look at this diagram, here x equal to 0 at the source. And the length of the transmission line is small l. Now, at the receiving end, y is equal to 0. అంటే y ఏ డైరెక్షన్ లో ఉంది? x కు ఆపోజిట్ డైరెక్షన్ లో ఉంది. x ఇక్కడ స్టార్ట్ అయ్యి ఇక్కడ ఎండ్ అవుతుంది, y ఇక్కడ స్టార్ట్ అయ్యి ఇటువైపు ఎండ్ అవుతుంది. అంటే ఏమని రాసుకోవచ్చు? x ఈక్వల్ టు మైనస్ y. సో ఇక్కడ x ప్లేస్ లో మైనస్ y ని సబ్స్టిట్యూట్ చేస్తున్నా. సో ద ఈక్వేషన్ బికమ్స్ v ఈక్వల్ టు a e power py plus b e power minus py. Similarly, I can be written as 1 by Z0 a into e power py minus b into e power minus py. So these two are the voltage and current equations in terms of small y. Now from these two equations, how can you define reflection coefficient? Eta equal to ratio of reflected by incident. So reflected ఏది? సెకండ్ ఇది. b e power minus py by incident is a e power py. So this can be written as eta equal to b by a into e power minus 2 into py. Now where we are calculating the reflection coefficient at the end. So end అంటే ఇక్కడ లోడ్ దగ్గర y value ఎంత? 0. So substituting 0, so this value becomes 1 and reflection coefficient equal to b by a. Now We want to find what are the values of this small a and small b. So at y equal to 0, what is the voltage? VR equal to, substituting in this equation, a plus b. Similarly, at y equal to 0, the current equation, I into Z naught equal to a minus b. So taking, adding these two equations, minus b will get, plus b minus b will get cancelled. 2a equal to VR plus IR Z naught and a equal to VR plus IR Z naught by 2. Similarly, b equal to, so subtracting these two equations, we are going to get b, VR minus IR Z naught by 2. So how can you define transmission line, reflection coefficient? B by A. So this can be written as, this B is VR minus IR Z naught by 2 by A. VR plus IR Z naught by 2. 2 will get cancelled. VR minus IR Z naught by VR plus IR Z naught. Taking VR outside, VR by IR minus Z naught by VR by IR plus Z naught. VR by IR is nothing but ZR minus Z naught by ZR plus Z naught. So ZR and ZL both are same. That is nothing but the impedance at the load. The impedance at the load. So like this, you can derive the expression for reflection coefficient. Now, three conditions which I have explained, you can write from these two. When the load is shorted, ZR equal to 0. I have already explained this. When it is short circuited, the reflection coefficient is -1. When it is open circuited, the reflection coefficient is 1. And when it is matched, the reflection coefficient is equal to 0. So this is about reflection coefficient. So why I am showing you this slide is, the whole thing, whatever I am showing you, you have to write in your answer sheet so that you will be getting full marks. See here the definition and the equations, and finally what is the equation for reflection coefficient, and what are the three cases. If you write like this, you will be getting definitely 7 marks. Is that clear, students? Now, there is a problem on this reflection coefficient. So a lossless transmission line is terminated in a load impedance of 30 minus j into 23 ohms. Find the phase constant and the reflection coefficient at a length of 50 meters. Characteristic impedance is 50 ohms. Wavelength is 0.45 meters. So what is the data given? ZL is given, Z0 is given, lambda is given, and length of the transmission line is given. So what is asking? Asking to find phase constant and reflection coefficient. So what is the formula to find phase constant? Beta equal to 2 pi by lambda. So 2 pi by lambda is equal to, already lambda value is given, substitute lambda here. So we will be getting 13.9626 radians per meter. Next, reflection coefficient. So what is the formula to find reflection coefficient? What is the formula to find reflection coefficient? Yes, Monica Devi, you can mute your mic. Okay, the formula for reflection coefficient is rho equal to ZL minus Z0 by ZL plus Z0. So already ZL is given, 30 minus j into 23 minus, what is Z0? 50 by ZL is 30 minus j into 23 plus 50. So this is nothing but 30 minus 50 minus 20 minus j into 23 by 30 plus 50, 80 minus j into 23. So if you rationalize this number, you will be getting rho value. So like this, you have to find out the reflection coefficient. So whenever there is a derivation, whenever there is a concept, so along with that, a problem will be there. So always be prepared. If you know the formula properly, definitely you can answer the problem. Students, when I am explaining the problems, you have to do it on your notebook. Otherwise, you cannot remember this. Is that clear? Yes or no? No response from your side, students.
Okay, sir.
You have to solve the problems in your notebook. Bhargav.
Okay, sir.
Okay, okay. So Bhargav is there?
సార్
Okay, వింటున్నావమ్మా?
ఎస్ సార్ ఎస్ సార్
నోట్స్ చూపిస్తావు ఇవాళ?
సార్
Okay, right. So next one is VSWR. Now we have seen what is reflection coefficient. Now we are going to see VSWR. VSWR means voltage standing wave ratio. Voltage standing wave ratio. So from the name itself, we can find it is the ratio of standing waves. So VSWR is defined as the ratio of maximum voltage to the minimum voltage. So this is the definition. Just if you remember this line, it is sufficient. Ratio of maximum voltage to the minimum voltage. VSWR is equal to Vmax by V minimum. So when there is VSWR, similarly ISWR is also there, right? ISWR means current standing wave ratio. Imax by I minimum. Now, on a transmission line, this is a forward wave and this is a reverse wave. రిఫ్లెక్షన్స్ వచ్చినప్పుడు ట్రాన్స్మిషన్ లైన్ మీద ఏం ఫామ్ అవుతాయి? స్టాండింగ్ వేవ్స్ ఫామ్ అవుతాయి. సో దీస్ ఆర్ కాల్డ్ యాజ్ స్టాండింగ్ వేవ్స్. దిస్ ఈస్ కాల్డ్ యాజ్ స్టాండింగ్ వేవ్ ప్యాటర్న్. Standing wave pattern means which is not moving in the forward direction. So it is reflected back. Now here if you see maximum voltage is there. So this point is called as Vmax. Next here, this point is called as minimum voltage or V minimum. అర్థమవుతుందా? Vmax ఎక్కడైతే maximum amplitude ఉంటుందో దాన్ని Vmax అంటారు. This part is called as Vmax. Similarly, ఎక్కడైతే యాంప్లిట్యూడ్ తక్కువ ఉంటుందో దాన్ని ఏమంటారు? V minimum అంటారు. ఇక్కడ ఇంకోటి ఏంటంటే Vmax దగ్గర I minimum ఉంటుంది, V minimum దగ్గర I maximum ఉంటుంది. Is that clear? Okay. So now Vmax by V minimum, that is nothing but VSWR. Now look here. What is Vmax? Vmax is nothing but Vi plus Vr, incident voltage plus reflected voltage. Similarly, we can also define V minimum is equal to incident voltage minus reflected voltage. Is that clear? Vmax is incident voltage plus reflected and V minimum is incident voltage minus reflected voltage. Now substituting these two values in this expression, Vmax by V minimum, Vi plus Vr by Vi minus Vr. So దీని ఎలా రాసుకోవచ్చు? Vi in కామన్ తీసారు అనుకోండి, 1 plus Vr by Vi by Vi in కామన్ తీస్తే 1 minus Vr by Vi. So VI will get cancelled. What is VR by VI? దీని ముందే చదివాం కదా, రిఫ్లెక్షన్ కోఎఫిషియంట్. So this becomes 1 plus rho by 1 minus rho. So what is this? VSWR. VSWR is represented with small s. VSWR is represented with small s. How you are representing reflection coefficient? Rho. So S is equal to 1 plus rho by 1 minus rho. Very, very important relation between reflection coefficient and VSWR. So S equal to 1 plus rho by 1 minus rho. If you apply componendo and dividendo, you will be getting the value of rho in terms of S. So here rho equal to S minus 1 by S plus 1. Rho equal to S minus 1 by S plus 1. These two are important relations. Relation between VSWR and reflection coefficient, and reflection coefficient and VSWR. Now the S value ranges in between 1 and infinity. The value of S ranges between 1 and infinity. Now you can ask me, sir, what is the practical use of this reflection coefficient? There are when you are calculating the incident power, transmitted power, reflected power, all these, we have to measure the reflection coefficient only. For example, in antennas, there is a transmitting antenna. So generally the antennas are connected like this. I will show you. So this is a source. And this is a antenna, transmitting antenna. So the source is transmitting some power to the antenna. For example, 100 watts power is transmitted to the antenna. Now, how we can say that the antenna is efficient antenna? If the antenna is sending all 100 watts outside, then we can say it is efficient antenna. Ideal condition only 100 watts will be delivered. Practical conditions, there will be losses during transmission, there will be losses in the antenna. Maybe if the antenna is 90% efficient, 90 watts will be delivered from the antenna. 90 watts deliver అయింది అంటే ఒక 10 watts ఏమైంది, రిఫ్లెక్ట్ అయినట్టే కదా. 90 watts డెలివర్ అయిందంటే ఒక 10 watts ఏమైంది, రిఫ్లెక్ట్ అయింది, ఆర్ ఇట్ ఈస్ లాస్ట్. ఐడియల్గా నో పవర్ షుడ్ బి రిఫ్లెక్టెడ్. ఐడియల్గా ఏం చేయాలి, యాంటెనా ఎఫిషియెంట్ యాంటెనా అయితే 100 watts ఇస్తే 100 watts ని బయటికి పంపించేయాలి. కానీ ఏ యాంటెనా ఐడియల్ యాంటెనా కాదు. సో the reflection coefficient should be very less. The reflection coefficient should be very less. In other words, what is reflection coefficient? Reflection coefficient can be defined as VR by VI, or it can be defined as PR by PI. If you are applying logarithm, it becomes 10 log PR by PI. What is PR? Reflected power. PI is incident power. ఇక్కడ 100 watts ఏమవుతుంది, ఇన్సిడెంట్ పవర్ అవుతుంది. 90 watts ట్రాన్స్మిటెడ్ పవర్ అవుతుంది. అంటే రిఫ్లెక్టెడ్ పవర్ ఎంత, 10 watts is reflected power. Suppose if you take 10 by 100, so approximately 0.1. అంటే ఈ వాల్యూ ఎంత ఉండాలి? చాలా తక్కువ ఉండాలి. ఈ వాల్యూ ఎంత ఉండాలి? తక్కువ ఉండాలి. సో ఇఫ్ యూ టేక్ దిస్ యాజ్ here 10 log 0.1. 0.1 can be written as 10 power minus 1. So 10 log 10 power minus 1. So this becomes minus 10 dB. Suppose in an antenna at 3 gigahertz, for example, take suppose this is frequency and this is return loss. So this is 0, 5, 10, 20, 30 like that. So loss ante negative scale lo ekku value unte takku power veltunnattu. So here what we are observing at 3 gigahertz, only 10 dB loss it is having. అంటే చాలా తక్కువ పవర్ రిఫ్లెక్ట్ అవుతుంది అన్నమాట వెనక్కి. అంటే యాంటెనా 3 గిగాహెర్ట్జ్ దగ్గర 90 వాట్స్ పవర్ని ట్రాన్స్మిట్ చేస్తుంది. 90 వాట్స్ పవర్ని ట్రాన్స్మిట్ చేస్తుంది. అంటే యాంటెనా యొక్క ఎఫిషియన్సీ దేని ద్వారా మనం క్యాల్కులేట్ చేస్తున్నాం? ఈ రిటర్న్ లాస్ ఆర్ రిఫ్లెక్షన్ కోఎఫిషియంట్, దీని ద్వారా మనం క్యాల్కులేట్ చేస్తున్నాం. సో దిస్ ఈస్ వన్ ఆఫ్ ద practical application of reflection coefficient. So in antennas we call it as return loss. In antennas we call it as return loss. This is one of the important parameter. All these parameters, reflection coefficient, standing wave ratio, all these are used for at high frequencies in antennas, in communication transmitters, receivers, oscillators. In all these components we are using these parameters. Okay, so that is the application of return loss or reflection coefficient. Both are same. So there is a problem on normalized impedance. This is about VSWR. So what is the problem that is given? See here. For a transmission line which is terminated in a normalized impedance Zn, find the normalized impedance magnitude and VSWR is given. So what is the given data? VSWR, that is S equal to 2. So ikkada em adugutunnadu? Normalized impedance adugutunnadu. Normalized impedance is given by ZL by Z0. What is ZL? Load impedance. What is Z0? Characteristic impedance. మన లోడ్ ఇంపెడెన్స్ ని క్యారెక్టరిస్టిక్ ఇంపెడెన్స్ తో డివైడ్ చేస్తే మనకు వచ్చేది ఏంటి? నార్మలైజ్డ్ ఇంపెడెన్స్. Now we know that S equal to 2. So 1 plus rho by 1 minus rho. So this is the relation between VSWR and reflection coefficient. So now 2 equal to 1 plus rho by 1 minus rho, or rho equal to S minus 1 by S plus 1. So 2 minus 1 by 2 plus 1, it is equal to 1 by 3. So we know that rho equal to ZL minus Z0 by ZL plus Z0. ఇప్పుడు రో వాల్యూ ఎంత వచ్చిందండి? 1 by 3. 1 by 3 equal to ZL minus Z0 by ZL plus Z0. So cross multiply చేద్దాం. ZL plus Z0 is equal to ZL into 3 minus 3 into Z0. So Z0 it తీసుకొచ్చేద్దాం, ZL it తీసుకొచ్చేద్దాం. So 4 Z0 equal to 2 ZL. అర్థమైందా? ZL it తీసుకొచ్చా, minus ZL, 3 ZL minus ZL, 2 ZL plus minus 3 Z0 ఇటువైపు తీసుకొచ్చా, it becomes 3 Z0 plus Z0, it is 4 Z0. ఇప్పుడు ZL by Z0 equal to So ZL by Z naught equal to 4 by 2. It is equal to. So ఏం అడిగాడు? Normalized impedance ZL by Z naught ఎంత అని అడిగాడు. So its value is 2. Like this, if you know the formula, definitely you can do the problem. Okay. So today's class I have I have explained about what is reflection coefficient and what is voltage standing wave ratio. Similarly, you can define current standing wave ratio also. I hope you people are following properly. If you have any doubts, definitely you can ask me. And regarding the problems, I will be sharing the PPT to you. So see in your mobile or in your laptop, solve the problems on your notes. Because without solving the problem, you cannot understand the concept. That is very clear. And definitely in EMWTL question paper, there will be problems. Don't think it is a theoretical subject. So if you know the problems, your confidence levels will increase. Your confidence levels will increase. Easily you can attempt the question. Okay. Next one. Next topic is transmission lines as circuit elements. So you might be wondering what is this circuit elements. There are two types of elements. So one is lumped elements and second one is distributed elements. Lumped parameters and distributed parameters. మనం ల్యాబ్ లో చూసాం రెసిస్టర్, కెపాసిటర్, ఇండక్టర్, like that many components. So physically we are seeing those components, those are called as lumped elements or lumped parameters. So we can verify, suppose there is a resistor, we can see how much resistance is there. Even if there is a capacitor, we can see how much capacitance that capacitor is having. But at high frequencies, we don't have these lumped elements, but they exist like distributed elements. That's why we call it as distributed parameters. Distributed parameters. Now, if you cannot see these distributed parameters physically, but we can feel their presence. Now, in this topic, I will be explaining how a transmission line will be acting like a inductor, when it is acting like a capacitor, when it is acting like a resistor. At different lengths, so at different lengths, it will be acting like an inductor, it will be acting like a capacitor, it will be acting like a resistor. Now the question is, why we need to make it as an inductor, capacitor and resistor? For again application point of view. Say for example, in a Yagiyoda antenna. Yagiyoda antenna is used as TV receiving antenna. So in that antenna, we need a resistive load, we need a capacitive load, and we need an inductive load. Okay, so in applications, suppose for even a matching purpose, suppose there is a reactance. It can be capacitive or it can be inductive. So if you want to match the capacitance with equal inductance, so you need an inductive load, and if there is an capacitance, if there is an inductance, if you want to match the impedance, you need a capacitive load. So at that time, we are connecting these transmission lines as equivalent loads in order to reduce the impedance. I think you followed why we need these as circuit elements. Generally, they are used at high frequencies only. See here, transmission lines at high frequencies, they serve as circuit elements. Even when you are taking the when you are designing an antenna, the antenna length should be lambda by 2. The length of the antenna should be lambda by 2. Why we are taking the length as lambda by 2? Is there any specific reason? Yeah, definitely. At lambda by 2 length, how a transmission line will behave? It will behave like a resistive load. That is the reason we are taking the length of an antenna as lambda by 2. So, at resonant frequency, if the impedance is resistive, whatever power we are giving at the input will be delivered at the output. Is that clear? So, that is why we are taking the length of the transmission line as lambda by 2. Next. Even one more disadvantage is at high frequencies, we cannot manufacture ordinary circuit elements. Ordinary circuit elements. And so, what we are trying to do is we are taking a transmission line, we are multiplying the phase constant and the length of the transmission line so that a circuit element can be produced. So that a circuit element can be produced. So the product of phase constant and the length of the transmission line, it is called as beta L. The product of phase constant and length of the transmission line is called as beta L. So beta is equal to 2 pi by lambda into the length of the transmission line. It can be lambda, or it can be lambda by 2, or it can be lambda by 4, or it can be lambda by 8, like that, different lengths. So if you are multiplying with this length, the phase constant, so different types of transmission lines can, different properties can be achieved by using different lengths of transmission lines. Okay, this part I will cover in the next class. So now I will be taking the attendance. Students, whenever I call, you open your video and respond. So A section. One second. Four not 7. 413. 413. 416. 420.
Yes, sir.
Sir, 416, sir.
416 present.
Yes, sir.
420. 21.
21 present, sir.
20
26.
present, sir.
Yeah, 20 present. 21 present. 26. 43.
26 present, sir.
Present, sir.
43. Okay.
Present, sir.
44. 45.
45 runs, sir.
49. 50.
50 present, sir.
54. 61.
54 present, sir.
present, sir.
66.
61 also
68.
present, sir.
Okay, okay. 66. 68.
68 present, sir.
Sir, 42 present, sir.
Intama?
430 present, sir.
430. Okay.
30, sir. 30.
Yeah. Given.
Okay, thank you, sir.
72. 69 అయిపోయిందా? 72.
present, sir.
72 present, sir.
75.
Present, sir.
76.
Present, sir.
80.
Present, sir.
82.
Present, sir.
84.
Present, sir.
85.
Present, sir.
89.
Yes, sir.
91. 95.
95 present, sir.
Okay. 97. 98. 97. కృష్ణ అంట. 97 నిద్రపోతున్నాడేమో. 99.
Present, sir.
A3. A4.
A3 present, sir.
A4 present, sir.
A6. A7.
A7 present, sir.
C0. C2.
C not present, sir.
C2 present, sir.
C4. D0.
C4 present, sir.
D not present, sir.
D5. D7. D8.
D8 present, sir. D7 present, sir.
E3. E4. F2.
E3 present, sir.
F2 present, sir.
E4 present, sir.
E4. F2.
F2 present, sir.
Okay. F2 present.
E3
F9.
present, sir.
E3 వేసానమ్మా.
Okay, sir.
F9 తర్వాత G3.
F9 present, sir.
G3. F9 వేసానమ్మా. F9 present.
G3 present, sir.
Okay. G5.
Present, sir.
G7. G8.
G8 present, sir.
H9. I0.
Present, sir. H1,
I0 present. Without I1 నా చాందిని.
Present, sir.
H1, sir.
I1 చాందిని.
H9
H9 వేసానమ్మా. వేసాను. నోట్స్ రాసావా H9?
రాశాను, సార్.
ఏది చూపించు వీడియో నుంచి. వెరీ గుడ్ సూపర్ ఎక్సలెంట్. వెరీ గుడ్. ప్రాబ్లమ్స్ కూడా ప్రాక్టీస్ చేయండి నాన్న ఇంటి దగ్గర. H9
సార్.
ప్రాబ్లమ్స్ కూడా నేను పీపీటీ పంపిస్తున్నాను కదా క్లాస్ అయిపోయిన తర్వాత.
సార్.
అయ్యో ఒకసారి చేయండి ఇంటి దగ్గర. ప్రాక్టీస్ చేస్తే మీకు అర్థమవుతాయి.
ఓకే, సార్.
4 G8 ఎవరు నాన్న? G8
present, సార్.
ఒకసారి వీడియో ఆన్ చేయమ్మా. G8 చరణ్ కుమార్. Charan Kumar has left the meeting.
Sir, 444 present, sir.
444. Present వేసానమ్మా ఆల్రెడీ. 444 is present. ఈ స్పీకర్ సాయి ఏమన్నా రాసినావా బాబు? 489 నోట్స్ రాసినావా? చూపిస్తావా? ఒకసారి ఆన్ చేయమ్మా. వీడియో ఆన్ చేసి చూపించు. నోట్స్ చూపించాలి.
ఇప్పుడే బ్యాగ్ లో పెట్టండి క్లాస్ అయిపోయింది.
సరే నెక్స్ట్ క్లాస్కి రెడీ అవ్వచ్చు.
Okay.
ఓకే. సో ఎనీ అదర్ డౌట్స్ రిగార్డింగ్ ద కాన్సెప్ట్స్?
Yes, sir.
You are receiving the PPTs, right?
Yes, sir.
Video recording.
Yes, sir.
Okay, just go through them. If you have any,
489 present, sir.
489 present చేశానమ్మా.
Okay, sir. Thank you.
Present చేశాను. Okay, students. Thank you. Thank you for your patient listening.